Now the next topic is inner product of vectors in R square and R cube space. If vector x is equal to x1, x2 and vector y is equal to y1, y2 are vectors in xy plane, that is R square, then their inner product is defined as x dot y is equal to x1 y1 plus x2 y2, that is also called dot product. Thus, for vector x with coordinate x1, x2, x3 and vector y with component y1, y2, y3, then x dot y is x1 y1 plus x2 y2 plus x3 y3. So thus, product of two vectors is a scalar vector, but product of a scalar with vectors is a vector, that is 2 times of 301 vector is, that is product of 2 with vector 301 is 602, again a vector. And if we take x dot y, that is 121 dot 342 is equal to 3 plus 8 plus 2, that is 13, a scalar quantity. So this is about the inner product of vector in R square and R cube. Now we will discuss properties of inner product. That is, first, vector x is equal to x1, x2, x3, vector y is equal to y1, y2, y3 and vector z is equal to z1, z2, z3 are vectors in R cube and K belongs to R, then inner product of two vectors is greater than equal to 0 and inner product of two vectors is equal to 0 if and only if vector is 0. That is, if we take x dot x, that is x1, x2, x3 dot x1, x2, x3 is equal to x1 square plus x2 square plus x3 square. So it shows that as it is a square, and sum of square, therefore it is a greater than equal to 0. Therefore, x dot x greater than equal to 0 is proved. And also, x dot x is equal to 0 implies x1 square plus x2 square plus x3 square is equal to 0. That is, if we see, this is the modulus of x whole square, because modulus of x is under root x1 square, x2 square, x3 square. Therefore, modulus x square is 0. This is possible if and only if modulus x is 0. This is possible if vector x is 0, that is x1 0, x2 0 and x3 0. So the third one is that is x dot x is equal to modulus x square. As we done in earlier part, that x dot x is equal to x1 square plus x2 square plus x3 square. So it can be written as, if we take, because square and roots are cancelled out, we can write it as form. So this is the mod x. Therefore, x dot x is equal to mod x square. That is proved. So number 3, x dot y is always equal to y dot x. That is commutative law is hold. Number 4, x dot ky will be equal to k into x dot y, which is also equal to k into x dot y. Result will be same in all three cases. These are the properties of inner product. So fifth one, if we have x dot vector y plus z is equal to x dot y plus y dot z. So taking left hand side, we have x dot y plus z vector is equal to x1, x2, x3 into y1, y2, y3 plus z1, z2, z3. So we get x1, x2, x3 dot y1 plus z1, y2 plus z2, y3 plus z3. That is, we get by inner product property x1 into y1 plus z1 plus x2 into y2 plus z2 plus x3 into y3 plus z3. So we get x1 y1, x2 y2, x3 y3 in first bracket plus x1 z1, x2 z2 plus x3 z3 in second bracket. So we get vector x dot y plus vector x dot z. These all properties are also valid in R square. So as these properties are valid in R cube, so it is also valid in R square. That is, if we take x1, x2 in place of x1, x2, x3, these properties are also followed by R square. Problem based on inner product. Find vector x dot y where vector x is equal to 1, 2, minus 1 and vector y is equal to minus 3, 4, minus 2. So the solution is vector x dot y is equal to 1, 2, minus 1 dot minus 4, minus 3, 4, minus 2. So as the rule of inner product, we get minus 1 into minus 3 is minus 3, plus 2 into 4 is 8, minus 1 into minus 2 is plus 2. So we get 7 as a result of inner product. So the next one is if vector x is equal to 5i plus 4j minus 3k and vector y is equal to 2i minus j plus 2k, then find vector x plus 2 times of vector y into 2 times of vector x minus vector y. So we have to find a dot product of these two brackets. So first of all, we will find vector x plus 2 times of vector y. That is, vector x is 5i plus 4j minus 3k plus 2 times of 2i minus j plus 2k, and we get 5i plus 4j minus 3k plus 4i minus 2j plus 4k. So we get 9i plus 2j plus k, and we have to find 2x plus y vector. We can also find in this manner also 2 times of vector this form plus here we have to find 2x minus y plus minus 1 times, because 2x minus y is 2x plus of minus 1y. So minus 1 times vector y, that is 2 minus 1, 2. So we get 10, 8 minus 6 plus minus 2, 2 and minus 2. So we get 8 and is here it is a mistake, that is minus 1 into 1 is 1. So it is 8 plus 1 is 9 and minus 6 minus 2 is minus 8. That is vector 2x minus y vector is 8i plus 9j minus 8k. Therefore, vector x plus 2y dot product 2x vector minus y is equal to 9i plus 2j plus k dot product 8i plus 9j minus 8k. So we get, that is 72 plus 2 into 9 is 18 minus 8 into 1 is minus 8. So we get, that is 72 plus 10, that is 82. So these are the problems which are based on the inner product.